Hello, my name is Andreas Blumauer, and in the next couple of minutes I will talk about semantic knowledge graphs. What is a knowledge graph? I will give you a first example, which you might know already. Google is using a knowledge graph since a couple of years to organize web documents. So if we search for, let's say, a company like Accenture, you would not only get a list of documents, you would get also a fact box like this one. You see it's a company, a short description comes from Wikipedia, stock price, where the headquarter is, the CEO, and so on. So it's more, let's say, a graph of things being connected to each other. I could now click on maybe a subsidiary like Evanate. I could click here, and what I get here again is again a fact box and also other subsidiaries of Accenture. So you see, it's a graph of things which is rather on top of the documents to deliver facts around things. Knowledge workers are not necessarily interested in documents. They would like to get information in the form of facts around business entities. So what does that mean in practice? I will give you a quick example of a semantic knowledge graph you might be familiar with. It's partly derived from the medical subject headings, which might serve as a core element of an enterprise knowledge graph within a pharmaceutical company. And this little excerpt of mesh should explain in a better way how a knowledge graph can help you to organize knowledge within your company. You see a couple of things here. The things are represented as blue circles. So this first thing is a body part. So you could attach anything to this thing. It could be an image, it could be a code, it could be any value, or if you look at the vocabulary around the things here on the right hand side, it could be synonyms, for instance. And it could be a category on top. So the fundoscope, for instance, which is related to this body part, is also a diagnostic equipment. And you can use the knowledge graph for text mining. So you can extract the entities, the things, from a text. And the knowledge graph also helps you to do this text mining very precisely. So it helps you to disambiguate things if they have maybe the same name but a different meaning, and so on and so forth. So this knowledge graph can be used for several purposes. And I will give you a little example based on a person, a researcher, maybe an analyst, who would like to do complex queries around document repositories. So you will see quickly it goes beyond search. And knowledge graphs are a very agile way to describe knowledge. So it's like a street network. It can grow over time. There are main streets, there are maybe some crossings between the streets. You can extend it over time. You don't have to necessarily define a schema in the very first round. It can become multilingual, for instance, and it can be very precise in a way because it's based on a standard, which is not just, a, a, a way to describe a graph without any logics behind. No, you can put ontologies on top which help you to make sure that your knowledge graph will stay consistent, and therefore the precision when later being used, for instance, for entity linking, will be very, very high. So let me show you this little example. A person is interested, let's say, in diagnostic equipments, all documents about diagnostic equipments. On the left-hand side, the traditional approach would necessarily need additional tags. So you would put there maybe a new class of documents, diagnostic equipment. On the right-hand side, you extend your already existing graph and you introduce this new category and link it to the existing concepts. And the concepts are attached to the document automatically. So you see the results are pretty much the same, but as soon as you want to extend this analysis and say, okay, but now just show me just documents about fundoscopes. On the left-hand side, you have to introduce another tag, and on the right-hand side, you introduce a new node in your knowledge graph, a new subcategory. So that can be further extended. What if the person is interested in ophthalmoscopes, which is we just learned, just a synonym of an already existing thing. You have to add, again, new tags to any of the documents you have already tagged before. On the right-hand side, no need to do anything except adding a new synonym to the already existing node. So you see it's much better maintainable in a way and extensible, and the quality of your metadata will be much higher. And what if the person is interested just in optical instruments and so on? You see here, you could build a polyhierarchy. So no need to do anything here with the metadata of your document. You just describe the meaning of an endoscope, for instance. You just state that that's an optical instrument. On the left-hand side, it's really embedded within the document. So that's actually the main difference. On the left-hand side, it's just metadata per document. It's implicit. It's not reusable. It's not, you cannot make it machine processable, really. On the right-hand side, it's really about knowledge about metadata. So you can reuse the knowledge graph. You can link it to other knowledge graphs later, maybe to MESH, maybe to ICD-10, maybe to DBpedia, whatever is out there, or even to the Google knowledge graph. So you see the difference. It's maybe a little shift in our minds to start thinking in terms of graphs, but it does a lot with the way we can later process and retrieve and analyze information. And that's maybe the key picture which explains all of that. We are used maybe rather to this three-layered content architecture. We have content, we might have some metadata, and on top we have some navigation logic or an application. But most of us forget about the semantic layer. And that leads to a disintegrated information management. We cannot really harmonize our metadata if we have metadata per repository. At least with some very important repositories, of course, enterprises take it very serious to establish a metadata layer on top. But this is not necessarily the right way to do a data integration later. So what we have to put on top also is a semantic layer, which provides explicit semantics, and most importantly, maybe reusing a standard semantic language, which is RDF and SCOS, and therefore you can use graph databases which follow those standards. For instance, to use a very powerful query language called SparkQL. I will explain that in the second video. And before I come to an end with this first part, one other thing which is important to understand, with knowledge graphs on top, it's possible to link unstructured to structured data. Because with RDF in place, which is kind of a lingua franca, you can transform any database schema, any XML schema, any implicit semantics of an Excel sheet into the very same ontology you're also using to describe your knowledge graphs when doing entity extraction from text. That means you can glue together somehow all the different data types you have in your enterprise and ask against the resulting linked data structure quite complex queries like the one I just put there as a little example. And in a second video, we'll show you a very concrete application which makes use of these principles I just described. Thank you for your attention.